Hello everyone, and welcome to today's lecture. I am absolutely thrilled you're all here, because what we're diving into today is going to challenge pretty much everything our textbooks have ever taught us about the birth of black holes. For decades, we really thought we had the universe figured out, at least when it came to how massive stars die and how black holes are formed. But recent data from observatories like the James Webb Space Telescope and NEOWISE, well, they've basically forced the scientific community to tear those textbook pages out and start completely from scratch. Here is our syllabus for today's class. First, we'll quickly review the classical paradigm. Then, we'll explore the silent death of stars. After that, we'll unpack the Webb telescope enigma. And finally, we will discuss how we're rewriting modern astrophysics.
Let's jump right into part 1, the classical paradigm, or the rules of the universe.
To truly grasp why this new data is sending shockwaves through astrophysics, we first need to establish our baseline. What were those unshakable rules of the universe that every astrophysicist just agreed upon? Think of this as a quick recap of Astrophysics 101. Rule number 1. When a massive star, specifically one with over 20 times the mass of our Sun, runs out of fuel, its core collapses and it dies in a spectacular, highly energetic supernova explosion, leaving behind a stellar mass black hole. Rule number 2. Supermassive black holes, those absolute monsters at the center of galaxies, start out small and grow very, very slowly over billions of years by accreting matter. And rule number 3, these supermassive black holes evolve in lockstep with their host galaxy, always maintaining a highly predictable mass ratio of about 0.1% of the galaxy's stellar mass. That's just how the universe worked, right? Clean, logical, completely predictable? That brings us to part 2, the silent death of stars. What happens when stars just disappear?
So, what happens when the universe simply decides to break rule number 1? What happens, class, when a massive star that by all accounts should explode with the light of a billion suns just vanishes into the dark? This introduces us to a fascinating and honestly slightly terrifying concept, the failed supernova. The latest data reveals a scenario of silent, monolithic implosion. Instead of a massive explosion, the shockwave generated by the collapsing core just fails. It stalls out entirely, completely swallowed by the star's own immense gravity. It happens so fast that the neutrino heating, which is the energy that normally pushes matter outward to cause the explosion, is completely cut off. No fireworks. The star just silently collapses in on itself. Some astronomers have even started calling this an unnova.
To really visualize the mechanical difference here, let's use a simple analogy. Think of a standard supernova like the demolition of a massive skyscraper using dynamite. It is incredibly loud, it's blindingly bright, debris goes flying everywhere, and the entire city knows exactly what just happened. A failed supernova, on the other hand, is like a massive sinkhole silently opening up in the middle of the night and swallowing a house whole. No noise, no scattered debris, just a sudden, terrifying absence where something massive used to be.
And the incredible thing is, we actually have direct observational proof of this happening in real time. If we look at archival data from NASA's NEOWISE telescope, astronomers were tracking a real yellow supergiant, about 20 solar masses, named M31 2014 DS1, located over in the Andromeda Galaxy. Back in 2014, it brightened in the infrared, which told us it was shedding its outer layer of dust. But then, fast forward to 2023, its visible light just dropped, dramatically and almost immediately. Today, all that remains is a stellar mass black hole. The star literally swallowed itself.
What's absolutely mind-blowing about this anomaly is the sheer scale of the drop-off. The star's visible light didn't just dim a little bit, it plummeted by a factor of over 10,000. Because that internal shockwave was too weak to blow the star apart, the majority of its inner core just collapsed in total silence, leaving behind nothing but a faint pale shell of dust. So, that first classical rule we talked about, officially broken.
Moving on to part 3, the Webb telescope enigma, exploring these cosmic giants.
The cracks in our classical paradigm aren't just limited to dying stars in our local galactic neighborhood. When we look back to the very dawn of the universe, things get even weirder. I want you to really think about this rhetorical question for a moment. How can a black hole, which supposedly is born from the death of a star inside a galaxy and grows alongside it over billions of years, be physically more massive than the entire galaxy surrounding it? Under the classical paradigm, this is an absolute logical and chronological impossibility. There is no way. But, as we'll see, that is exactly what the James Webb Space Telescope just found. The ultimate example of this paradigm collapse is a system called Able 2744 QSO1. In the JWST data, it shows up as a little red dot, observed as it existed just 700 million years after the Big Bang. We're talking about a tiny system, only about 1,300 light-years across, but thanks to a perfect cosmic alignment, this system was heavily magnified by the gravitational lensing of a foreground galaxy cluster. This incredible magnification allowed scientists to map the motion of its gas using real direct visual data from Webb. They tracked pristine hydrogen and helium gas moving with Keplerian dynamics. That means the gas was orbiting perfectly and at incredibly high speeds around a mysterious, insanely heavy central point, just like planets orbiting a sun.
When the scientists actually crunched the numbers and calculated the mass of that central point based on the gas's movement, the result was absolutely jaw-dropping. 50 million solar masses. That is the sheer weight of the supermassive black hole lurking inside this ancient, tiny galaxy. And this right here is where the textbooks are officially thrown out the window. Remember our third rule? That neat, predictable 0.1% ratio? Look at the mass distribution in this early universe system. The black hole does not make up 0.1% of the mass. It accounts for a staggering 66% of the system's total mass, compared to just 34% for all the stars. Let that sink in. This black hole isn't just a little bit oversized. It weighs almost twice as much as all the stars in its entire galaxy combined. The coevolution rule? Completely shattered.
Which brings us to our final section, rewriting modern astrophysics. Let's look at the new theories. As scientists, when our instruments give us irrefutable data that completely contradicts the standard model, we don't ignore it. We rewrite the science. We need entirely new theories to explain our universe. Roberta Maiolino, the lead researcher of the Cambridge study on QSO1, summed this up perfectly. He stated that this is quite literally a paradigm shift, a total revision of the classical scenarios of how black holes form and grow. The scientific community is in the middle of this shift right now. It turns out black holes aren't just the end products of stellar revolution, they are something much, much more primordial.
One of the absolute front-running theories to explain these primordial cosmic monsters is the heavy seed theory, also known as the direct collapse model. Instead of a star being born, living its life, and dying, this model proposes a cosmic shortcut. Step 1. In the early universe, massive clouds of dense, pristine gas form. Step 2. Due to extreme conditions, this gas is actually prevented from cooling down and fragmenting. This means the normal star creation process is completely bypassed. No stars are ever born in this cloud. Step 3. That entire massive cloud undergoes general relativistic gravitational instability and collapses directly into a giant black hole. We're talking about a black hole starting its life at 10,000 to 100,000 times the mass of our Sun, skipping the stellar phase entirely.
But direct collapse isn't the only radical theory gaining traction right now. What if these are primordial black holes? This theory suggests they were formed from the direct crushing of quantum density fluctuations just fractions of a second after the Big Bang itself. If true, that would mean black holes acted as the very first gravitational anchors in the universe, and galaxies actually assembled and grew around them much later. There's also the wild concept of quasi-stars, embryonic black holes wrapped inside massive envelopes of gas supported by radiation pressure. This setup would allow them to gorge on matter at super-Eddington rates, basically devouring material vastly faster than the standard laws of physics would normally allow.
The data from Webb and NEOWISE is absolutely clear. Stars can vanish without a sound, and massive black holes were lurking at the dawn of time before their host galaxies were even built. Modern astronomy is being turned completely upside down. So, as I wrap up today's lecture, I want to dismiss you with this thought to chew on. If it's now proven that black holes were born before the very galaxies that house them, when you look up at the night sky, what other cosmic monsters are hiding in plain sight, just waiting in the dark? Thank you all so much for your attention today, and keep looking up. Class dismissed.